All right, I just wanted to create a quick key for this vertex form homework. We'll just jump right into it. When I go to sketch one of these functions, I want to know what the a, h, and k values are. Here the a value is -1, h value is -3, and the k value is -4. They all come straight out of the equation. The only trick is remembering to always flip your h value. From this, I know the vertex is -3, -4. Let's plot that point. All right, and then I can use my a value to find the next point going one unit to the right. Now, let's just remember this pattern here. 1, 4, 9, 16, 25. These are all my squared numbers. So I went down 1 from the vertex. Next, I'm going to go down 4. All right, connect the dots. And not my best, but that is that parabola. All right, for this one here, a equals -1, h equals +2, k equals 4. I want to put a point at 2, 4. Go down 1, make it symmetrical. And then the next one, I went down 1, so now I'm going to go down 4. And connect those points up. Notice our a value is negative in both of these cases, and both of them open down. Good thing to remember here. Okay, so if my x squared values are 1, 4, 9, and 16, then when a is -2, so -2 times x squared is going to become -2, -8, -18, -32. So that's going to be the increments that we're going to change by from our vertex. Okay. A equals -2, h equals 4, k equals 4, put a point on my vertex, 4, 4. And now I want to go over 1, down 2, and then down 8 from the vertex. Always measure from the vertex. Make it symmetrical over our axis of symmetry, and connect the dots. Other options would be using our calculator and then using the table feature to get these values, or creating a little table ourselves of x and y values that we can plot. Okay, here a equals 1, h equals 1, k equals 2, 1, 2. Go up 1 to both sides. Then I want to go up 4 from the vertex. Connect up our points. That's number 4. Number 5, I want to go, my a is equal to -2, h equals 1, k equals 1. Let's go to the correct hk. It's right there. Go over 1 and go down 2. And then the next is down 8 from the vertex. Get one that looks like this. 2, -4, and 2. Put a point at our vertex. Our first point is 2 up, but then it goes up 8. So you might notice there's not many options for what it goes up by. And it's all just multiples of our squared numbers based on that a value. So if our squared numbers are 1, 4, 9, when we see a 2, we want to go up 2, 8. And if there's room on the graph, we would go up 18 from the vertex. All right. Write the equations in vertex form. So I want the h and the k value. This is -4, 2. is my vertex. So in my A value, a handy trick is just see how much you go up. Once you go 1 over from the vertex, I go over 1, I go up 1, A is 1. H is -4, and K is 2. Plug that into our equation, we'll get y equals x minus a -4 or x plus 4 squared plus 2. This one here, our vertex is at 1, 3. Let's get y equals x minus 1 squared plus 3 for the a value. Just forgot about my a value there. Look and see, once we move 1 from the vertex over, we go 1 down. So 1 over from the vertex, we go 1 down. That makes our vertex just a -1. I don't have to write the 1, I can just put a negative there. H comma k here is 4 comma -7. If I go 1 over from my vertex, I go 2 up. So a is going to equal 2. Let's write the equation. Y equals 2 times x minus 4 squared minus 7. This one here is a little bit tricky. The h and the k value are easy to get. H is equal to -5. K is equal to 0. But that a value is hard to see because if I go 1 over, this isn't an ordered pair. This is kind of a fractional point. So an idea would be to draw in our normal parabola, which would go up 1 and then up 4 and then up 9, which would be off the graph, and see how much we have to shrink it by to hit this line. It's actually much easier to see on this second point that this point here is 1/4 the height of that orange point up there. So my a value is 1/4. This parabola here has been flattened to 1/4 of its original size. Here, let me connect this up so you can see this is like our parent function, parabola, and then it's been smushed down so that every point is exactly 1/4 of the height. So that gives us 1/4 for our a value. Y equals 1/4 x minus h, which becomes a +5, and then that's squared. All right, describe all of the transformations. Here, I like to do this just by drawing arrows and saying what each thing does. A minus in front, for example, gives us a vertical flip. This 2 is going to move us to the left 2, and then this -3 is going to move us down 3. Here, the negative causes a vertical flip. The 2 causes a vertical stretch. The -3 moves us right 3. And then the +1 moves us up 1. That 2 is going to cause a vertical stretch. That -3 is going to move us to the right 3. And that -4 is going to move us down 4. One more. Vertical flip, because it's negative. I'll put in parentheses. After vertical flip, I'll say that this one's going to open down because they normally open up. But if you see a negative, it causes it to open down. That 2 is going to be a vertical stretch. If that number was less than 1, like 1/2, for example, it'd be a vertical compression. This will move us right one. It's always the opposite of what you think. Right one and down two. All right. I'll add back in. This one's going to open up. This one's going to open down. And this parabola here is going to open down. All right. I think that was a pretty good quick summary of vertex form. Check out the PowerPoint if you need even more help or use other online resources.